Hey there, this is Jenny Chen. I'm the founder of 3D Heals. Welcome to the Lattice podcast, the official podcast for 3D Heals. This is where you will find fun but in-depth conversations with technological game changers, creative minds, entrepreneurs, rule breakers, and more, focusing on how we can use 3D technologies like 3D printing and bioprinting to reinvent healthcare and even life sciences. This podcast will also include AMA or Ask Me Anything sessions, past Instagram live interviews with influencers, and other direct engagements with our tribe.
Thanks for joining us. We're starting right on time. Perfect. So who we have today is the CEO and founder of Xkelet, Jordi. I hope I'm pronouncing your name right in Spanish fashion. We have a lot to talk about because I actually know you maybe very early because I remember I met you first time in Barcelona during a conference. Yep. And you were pitching, and I actually was very impressed with your pitch. I was very new to 3D printing, and then you sent me your bio recently. It seems like you also started starting in 2014. It seems a long time ago, but it's still pretty recent, I would say. So today I kind of just want to know your story. Starting from 2014, you were not an engineer by training, but you eventually moved to where you are today, which is basically an engineering firm. So you want to tell us how you started in 2014?
Yeah, we had another company in that time. Well, it's already existing. A company focused more in software and design development. And one of those days, one of our partners broke a leg. And well, for my free time, I decided to make something to solve that. So using my previous experience in 3D design and 3D printing for other projects in FDM in that time, we started making something, something like thinking in the morphology of the braces and my previous experience in broken bones, because I broke some parts of my body before. And I make a design that maybe you can find in the early stages in the Facebook, like was something different that we have right now. Mm-hmm. And well, when I make that, I show that model to one of the presidents of upper extremities here in Spain. And they said, well, I like that. I think that you can move forward with those. And well, that was a starting point for Xkelet to start working in that kind of health market, that it's super fun but super hard to do it, to be there.
Yeah, and you were pretty new to the space in general in healthcare.
I mean my experience in healthcare was more in personal experience for some years or whatever, but I don't have previous skills in that. So I learned at the same time. I was getting meetings with professionals in the sector, surgeons, traumas, orthotic, and well, getting experience. Right now I know a little bit more when I had in 2014.
I think you know a lot more now.
Yeah, well, I suppose. Hopefully.
So let's go back to 2014 first, because I think the original version of your first design, you were trying to solve probably your own fracture problems, the problem that you were experiencing yourself. How is a version 0? How did it look, and what problem are you trying to solve?
When we start in that point, my concerns was regarding weight, itchy, shower, breathable, and fashionable, and so that was my idea of concept initially. Okay, so what I made was a design. I take the starting point from the muscle design of the arm. And I take that design generating the windows, not like a Boronoid and with holes and that's it. My first idea was, if the body is making like this way with the muscles, let's follow that path and make something like that. And that stage, the idea was, I don't want just to make something hard. I want to make something soft inside to have a little bit of cushioning. So in that stages, we start making prints, with EOS and 3D systems at that times, to print hard and soft at the same time. Okay. Today we realize that this is not necessary, but at that time was we made. And without any kind of concept of closure systems. I mean, the idea was to make two shells and with some screws, put it there together, and that's it. That was the concept. And well, was not bad, but much more better what we have right now.
So based on the information that you sent me, I would summarize the evolution of Xkelet into 3 big parts. One is software evolution, is getting better. The design is getting more intelligent. And then 2 is materials. You guys have been getting a lot of certifications of different kind of materials. And then I'm missing out. What's the 3rd part? Let me take my notes. Global expansion. Your 3rd part is global expansion. And, exactly. And you've been basically growing into different parts of the world every year. It seems like this is your approach. So I would just like to structure our conversation around these 3 points. Okay. And if you want to, you can show some examples if it supports your story. So the first part I want to ask you is about the software part. Was this the original idea behind Xkelet?
I mean, when we started with Xkelet, the idea was not to make a company, was to make a hobby, to make something for me, well, to test it. And after that, I saw Cortex to make some project from the school, etc. And later on, in half a year or 1 year later, Active Armor starts. That was in that time was called Amphibian Skin, I think, the company. And the idea was that, but later, working with these traumas that we had together, we focused into design something to solve not just these issues that was thinking that was the only ones. The surgeons, traumas, orthotic, they make me to realize that there was a lot of other kind of things that to solve, like muscle mass decrease, ulcers, infections, whatever. Okay, a lot of the stuff to solve from the traditional methods, plus the thermoplastics and orthotic. Okay, so we was focusing that. But when we had that done, and also we won the Red Dot Award later, blah, 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 but we realized that said, okay, guys, I mean, if this have to be a company, we have to get some revenues. And we have to get some revenues, we have to find a business model. And I become from a software background. So for me to make manual things every time doesn't make sense. I mean, it makes sense if you have a huge project and you take manual and you sell it and that's it. But if you have to sell little things, personalize it and make it manually, for me, that was no sense. So I said, I mean, if I have to be involved in that, I don't want to make this manually, because I don't want to have to hire a huge amount of people and to design every single time, every single immobilization, because always my concept was optimization in terms of how to make a big business with less people as possible, to control as much as possible, to maintain the beta as higher as possible, to be scalable. So in that point, we start with our background and we start designing a software capable to do what the manual, some industrial designer does, automatic. Okay. So at that point, we start finding issues, etc., and we start defining the process. And right now, the process that we have is scanning process, identifier to identify the morphology of what you're scanning, and the builder that is designing the cast with our own interface of artificial intelligence. That's simplified, it's what we are doing, and it's the core of the company, and they give us this scalability.
Yeah, so now that on your website it says only takes 2 minutes to go from 3D scanning to ready to print.
Scanning is around 10-15 seconds. Identifier, the external morphology, fingers, bones, etc., it's 30 seconds more or less, and the builder takes 60 seconds. This is the average time. You have to consider maybe 1 minute more to enter some data of the patient and choose what kind of immobilization that you need. And after that, it's done, sent to production, and the cast is it's up in the cloud. And saying that, it's where we are going in terms of what you said about resins, materials, etc. in certificate. Well, at the end of that point, we realized that we have a good product and we have a good software. Well, in that stages was not as evoluted that we have right now, but was impossible to sell the immobilization to the medical field, because to make one cast took, I don't know, 5 hours, 8 hours, 12 hours, this printing, after that post-processing. But if we was working in FDM, the price was considerably low. But if you was working with SLS or SLA or polyjet or other kind of more specific technologies, the price, the cost prices was around $380 to $300. So that was impossible to sell in the market.
Yeah.
So at that point, we start working in our own printers with a partnership with a UK company, and also in resins, and also focus in getting certifications from the resins to be available to install that all the systems in the hospital centers, wherever. So these days we are capable to print. I think we are the fastest printing technology right now in the market, because we can print 30 centimeters more or less in 45 minutes. And with the fast printing material that it's more focused for 1 month to 8 months immobilization. And for long-term immobilizations, we have other materials that are a little bit more time to printing, that we are talking about 2 hours to 6 hours more or less. But it's for orthotic market, that it's another story. You don't need that immediately time to be placed. But well, it's what we have right now, and it's how we focus our business model. I mean, step by step, handicap by handicap, we had the consequence to develop the next step and the next. Well, that was our story a little bit.
That's interesting. So you started off basically a software company in a way, but the product is too expensive using existing printer and materials. So to solve that problem, now you're inventing your own 3D printing systems that's faster and cheaper. Is that correct, my understanding?
That's correct. And was not just the technology, was also the concept of the people who was working in additive manufacturing, in terms of how they make business. Like we know everybody, and I understand the position. If we are a manufacturer of a printer, you want to sell that printer to everybody. If somebody wants to make a plaster, so a product like us, or somebody that wants to make, I don't know, mobile cases or whatever. So you have to open that margin of product capable to do with that printer. So you need to be not specific. You have to be to get a lot of possibilities to the market. So that it's a good part, but also it's a bad side, because you cannot be specific. You cannot be powerful in one kind of products, because you are not designing, focusing that. And also you are thinking in pre-print or make prototyping with 3D printing, like to be a little bit more cheaper than injection molding. But the professionals was not thinking into print one product and put that product in place in the market as fast as possible, as cheap as possible. The idea was, I want to fill all the platform, and when I have all the platform filled, I'm going to send to production to get amortization of the machine and the material, and after that put another platform. That's the concept of production, of industry. Our concept was, if I want to make one cast now, I want to put one cast cheaper, faster, and put in the market. That was the difference of the concept that we have in that stages, and for that we had to move to that state, to that point. I mean, we are not super special. I mean, we are pretty good, and we have good partners to reach that goals. But at the end, what we make was focus in one kind of solution. So that is what give us that possibility to reach that goals.
Yeah.
And it's super special, it's super good. But I mean, always Xkelet will be a software company, because without the software, you had to design more or less manually automatic processing CAD software, but you are going to need somebody to be attend that client. Okay, for me doesn't make sense. I mean, for me it makes sense that if somebody need it, do it for themselves. They don't need us. Just with the software, they do it for themselves. And if they want to make one, and at the same time there are 10,000 people making the same, they have to be capable to make 10,000 units at the same time. And that what give us the potential to be massive.
So now the question is, so it sounds like anyone can just buy your software and then use it with their own 3D printing systems. But 3D printing system. So, I mean, is this a whole complete package people need to buy, from the materials, 3D printer, and the software all together to make things work the best?
I mean, we used to work with distributors. I mean, people who are companies or change of hospitals or orthotic centers or wherever there are, or pharmas, or there are, or medical device distributors who wants to introduce our product in territories. Okay, and we make agreements with them. Okay, at that point they can decide. I mean, we advise them that if they use our technology, we are going to give all the traceability of the product with all the certifications and the guarantees that the end product will be right.
I see.
But if, I mean, I cannot tell them that, no, you need to buy that printer, yes or yes, because some of them, they make investment, or they are production centers, they already invest $1 or $2 million in machines.
Right.
So we have to give them the option that if they want to print with their machines, they are going to print with their machines. But they have to have, or they should have, the certifications requirements to that stuff, because otherwise it's complicated for us to defend the final product. But we give that option. For now, we are working with distributors worldwide. We are in 8-9 countries today, and we are trying to open more with the COVID situation. But and well, this is our story and way how to open the market for now. But in that stage, the distributors that they have to move that in the territories, also they make the same. I mean, they talk with the professionals, they talk with, and if they have printers, maybe they are going to use the printers, or maybe they are going to use ours. I mean, the good thing of our printer, it's you can get a lot of production with super cheap price. I mean, we are talking that our printer cost 5 times less than HP.
Right.
With around between 3,000 to 7,000 units a year production. So, well, it's an option, and it's good for us because it generates revenues for us. But we cannot say no. You should have to do it with our printers.
That's a really interesting business model, Jordi. That you started off as software, but then you kind of have this add-on hardware component. What made you decide that the economics work out? Because hardware is a lot more expensive in general to put it into your business plan.
Yeah, I mean, our main monetization system, it's the royalty immobilization. So every time that you design an immobilization and send to production, that means 1 unit, and they have to pay for every unit. Our software is centralized, so we control all the licenses. So we know how many units all the providers are making. So it's easy for us to invoice that units. Okay, but that's true. Also, we have revenues from the printers and from the consumables, and it's a good part from us. But is maybe in the early stages it's a part from us that generates good revenues, but this is something that in the future it's going just to get maybe 15% or 20% of the revenues of the company, because when the printers will be there, or they have other printers working, not
Right.
maybe just or us printer, because we work with that printer, but I mean, we don't know what is going to happen in the next years. We continue working with our partners, but if they are going to be another one, I mean, we have to continue moving with a wave of evolution. I mean, we cannot be close in everything. But one point of interesting of hardware, it's a little bit not related with that, but hardware for us, it's or 3D printing, it's a system to produce something. I mean, sometimes when we thought in 3D printing, it's like, oh, 3D printing does everything. No, we have to think that 3D printing is a tool. It's a tool for something, and every brand and every printing system, it's super good for one kind of things or one kind of business model. And also for us, 3D printing was not just a tool to produce something in the market, was a tool to demonstrate that to the medical field that this was possible. Because when we had the software and we had the immobilization, nobody believed us that that kind of solution will be something that can substitute plaster, thermoplastic, or orthotic system. Because they said, no, 3D printing is low, it's bad, doesn't have a structural strength, it's not going to work, blah, blah, blah. Okay, so we had to produce that in that pricing, super low prices, cost, super high speeds, etc., and good quality to demonstrate that this is real and this can be done in the market. And that was the hard part from us, to make them understand. Still having it's still being hard to show to the people, to believe in this is possible. From us or other companies that are in the market, that they come after us, but they are finding the same things that we find before. So, well, it's a consequence of evolution.
Yeah, absolutely.
If we had this conversation in 5 years, I think will be totally different, and maybe we'll be talking with another new things that we didn't thought before today. So
yeah, you guys definitely move very fast, and I think now is a good time to show people what are these incredible designs that we were talking about. So guys, this is an interview with the CEO and founder of Xkelet, Jordi Tura, and his company basically does focus on a software to design a cast for immobilization if you have a fracture. I just wanted for those who just joined us know what we're talking about. So Jordi, do you have some examples of the cast that you guys did?
I had no samples here, but I can show you some images if you want, because, well,
I don't know if we can do. Oh, you have actual physical images?
Physical images?
No. What kind of images are you gonna do?
No, I mean, I can show you images from the computer. I don't know.
Okay.
We can share images in the live.
We cannot share, and I don't want to lose you on this camera. So if you can direct the camera to the image, maybe it'll work. But
yeah, I think we can.
But everybody, you can also go to the Instagram on Xkelet to see their images. I also shared one image this morning of the cast. I have a couple questions about the design. We can just talk about it. It's fine. I think people can find that image. First of all, it looks like a mesh, right? That's I'm guessing you want the skin to breathe. You don't want to be in a solid cast. And then I also see these circles on the cast. I'm not really sure what those are for.
We talk about windows.
Yeah. Okay.
I mean, most of people when we start when we started 2014, I think after 1 month or something like that, the Cortex company make the design of the Voronoi. At that time, I didn't remember the Voronoi design. I know that the Voronoi design because I'm 16 years in 3D designing, but I didn't thought into make Voronoi design. But our design looks like a Voronoi, but it's not a Voronoi. I mean, our design is based we don't design based in the Voronoi algorithms. We design more based in the morphology of the injury.
Mm-hmm.
Okay, so depending of how the arm, the leg, the hand, whatever has, we change that design. I mean, the artificial intelligence changed the design because everybody is different. We have different position of the finger, different position of the bones, scars. Well, people it's a little bit thicker. Another one is a little bit heavier. I mean, changes. So
Right.
these windows moves in different kind of concepts. One concept is logical, is a structural because it needs to be a structural in terms of resistance. The other thing it's important is regarding to leave spaces open. What kind of spaces? There are some critical spaces in different kind of parts of the body
Mm-hmm.
that have to be open because otherwise generates scars. Like
Okay.
for example, if we are talking about this bone here, you cannot close it. Well, you can do it, but you are going to have some scar here, or you are going to burn the skin, or if you get some serious issue, can go much farther. Okay,
Mm-hmm.
but this is a simple sample. But also
Right.
in the legs or in the fingers, you have to you know how to immobilization of the finger. You know that somebody prefers to use this area to block the finger. Someone's prefer to block here. Someone's prefer to use the hard line. So all of these little things, it's something that we take care of it and we design based in it that areas. The third question, the third reason of that, it's obvious, breathable. Okay, we need to be as open as possible for one reason. One reason it's easy to take a genic, it's easy to dry it, but also the body feels that you don't wear anything. And also it's not a compression system. When you compress something in the limb, the lymphatic system said, okay, something happens there. I'm not going to move too much energy in that area.
Mm-hmm.
This is, I mean, you can find a lot of studies of that. This is nothing new. Okay, so what we are doing, it's a shell. Okay, like competitors are doing. Some ones they use straps that was more compressing. It's another
Yeah.
story. But if you are using a shell, what you are doing is not compressing. If you are
Okay.
not compressing, the arm or the leg or the body feels like, well, I have something there. I cannot move too much, but it's not compressing me. So, well, I will still working on I'm still putting energy in that area. So that's give us the result that decrease less muscle mass,
Mm-hmm.
the skin health is better. Uh, well, there are some little tips that are good. For sure, we have to make more studies to give more like more things like to be super. I mean, like some important things in terms of related in the studies that I cannot say right now because somebody has said no, this is not true because well, okay, so it's something that's related more clinical studies that we are running.
Mm-hmm.
But yes, it's something like that. And also the last one and not less important, it's they are critical parts for the professionals that they need to use electrotherapy, magnetotherapy, or hot lamps or whatever, or taking cures of the scar if it's a surgery or whatever. So are open tools to take to make that well to make that ways to recover, okay, or to push the recover with that tools
Mm-hmm.
to move forward faster, okay.
Yeah.
Also if you make an x-ray, it's better you have less parts because otherwise you're going to see the top of the mesh blocking the bone, so you cannot see exactly how it works the x-ray without remove it.
I see.
So well, and there are some little things that if you have a broken bone in some area, we used to leave some window there. If you have to make X-ray to see exactly how it goes without taking that off. In some cases, it's impossible because there are some structural parts that go for critical cases, and well, they have a percentage that it's impossible to solve it, but it's low percentage. But well, always we are looking for to solve as much percentage as possible. 100%, it's impossible. I mean, plaster doesn't solve 100%. Thermoplastic doesn't solve 100%. So
Yeah.
it's in medical field, 100% doesn't exist.
Yeah. So, that's a really interesting conversation, because, if you have a fracture, there, like you said, everybody's fracture is going to be different. Some people can be helped by a cast. Other people need surgery or some kind of reduction. How does it work? Is it usually the doctor would order this cast for the patient? Do they specify what kind of design they want or what kind of fracture this is so that you guys can put it into the computer? Somehow the computer can figure it out what kind of design is going to be the best for the patient?
Yeah, I mean, at the end of the day, the user will be the professional. And the professional, when we are going to attend the patient, they are going to check the X-ray or the DICOM or wherever they have to check, and they are going to decide what happened with that patient. I mean, broken bone with displacement, maybe need surgery, so go directly to surgery. After surgery, right. A scan, make Xkelet, leave home.
I see.
Otherwise, it's a muscle disease, chronic pathology, I don't know, deformation congenital for trauma, or broken bone without displacement that you need to make a redirection first. So, but in all the cases, the professional is going to identify what happened there, like normal they are doing right now. So we use an app. This app is calling to all the software that is in cloud, but at the end of the day, it's an app that you use to use the software. So you choose what you want. I mean, this guy has a wrist fracture from radius. I mean, this need a forearm with thumb, short spiga, with large immobilization down to the elbow.
Mm-hmm.
Choose, scan, identify, build, have it, send to production. That's it.
Is there any way people can test this app out for free, or you have to pay to experience what?
The software, you can download it for free for demo from the App Store. If you have an iPad and you have a structure sensor, or you have to download our bracket with our mirror, that is our new scanning system that is much more accurate than the structure sensor. But the structure sensor still works. And they can test for sure. But if they want to use it, they should have to be a distributor. We are not going to give that solution to private clients.
Okay, cool. Maybe I'll try it out. I do actually have a structure sensor that I bought many years ago. I never used it.
Yeah, you can use the normal one or the Mark II if you want. But I mean, it's pretty easy. You will see. It's not too much difficult. Just to be secure that not to be in front of the big window, and that's it.
So our time is running out, but I still have another question that I kind of forgot to ask, and I think it's kind of important. It's the concept of personalized cast, personalized immobilization. I definitely understand having a mesh with, breathing cast is a lot more comfortable for the patient, and the modularity where you can take things off to do X-rays and stuff. But the personalization stuff, is that really important? How important is it? Because we can have a small cast for a small patient and then a large cast for a large patient. Yeah. What part of it is really beneficial for the patient and for the doctor?
But what you are saying, personalization, do you mean the cast itself, not colorizing or processing, right?
Yeah.
You're talking about personalization. I mean, to make something special for every patient, it's super important. I mean, it's crucial. It's like something what happens right now with the masks.
Yeah.
People are making masks or injection or 3D designing or the fabric masks. The big problem of the masks is doesn't matter if it's FFP2 or N95 or N99. The problem is doesn't fit.
Right.
It's impossible to fit with sizes. Impossible. You have to stretch hard, and if you stretch too hard, you cannot use it for more than 1 hour. So it's the same that Xkelet. If the most similar thing to Xkelet is plaster or thermoplastic, because it's personalized for that patient. When you make an orthotic and make it use hot to a mold a little bit and to put there, always produce problems because it's impossible to mold perfectly to the ergonomy of that patient. And also the ergonomy of that patient changes. So you need to be available to change with the patient. And that is impossible to do it with the traditional methods, because if you make a plaster, after 1 or 2 days you can move everything inside. That, I mean, in some cases of, I mean, if it's moved a little bit, it's not bad. In some cases, people feel said it's okay, micro movements to recover fast. Okay, but the thing is, we need to not just personalize it in the morphology, also personalize it in solving all these areas that I told you before.
Right.
Because that is what gives us the comfort to the patient and to recover with, I mean, the day-to-day, to be, how to say that, maybe more, I mean, to be as good as possible when you are injured. Okay, you know that you are injured, but why you cannot to be comfortable with that? So, I mean, one of the problems that we have, that we have to tell to the professionals is, when patients use it, we have to tell them, remember that you have a issue, you have a injury, okay? Because they feel super comfortable and they start playing, washing dishes and making like normal way. And no, I mean, we don't make miracles. Maybe in 10 years, but today I cannot make miracles. And they need to remember that it's a super good solution, but you need to be calm. You need to rest. But this is what happened, and this is a super good indicator that tell us that they feel comfortable,
right,
and they feel secure what they are wearing.
Right.
So, because it's a shell, it's hard. So you know that if you receive an impact, you are protected. So, well, it's a balance between to be as much efficient as possible and to be as comfortable as possible. And also the fashion part. The fashion part is a good point, because it's related with the hygienic. After 2 days to wear a fabric immobilization, orthotic, or plaster, that smells not too good. So it's important to be hygienic in all. I mean, if you use it for 1 week, it's not a problem, but some ones they have to use it for 3 months, and that's another story.
Yeah, no, I think I get it now. I think the most important points from what we just talked about is the functions behind the structure, both, but in particular the functions that are offered by this kind of personalized device are really important for better health, patient care. So, well, thank you very much, Jordi, for today's interview. I still have a lot of other questions, but I think we're running out of time. Maybe another time. I know you guys also did a lot of work for COVID, and maybe another conversation soon. So thank you very much. Thank you, everybody, for joining us. Okay, bye-bye.
Bye-bye. Bye-bye, everybody.
That's it for this episode. Be sure to follow us on Facebook, Twitter, and Instagram at 3D Heals, and check out the links in the show notes. See you next time.